Hello everyone, we're just going to finish up these notes for today and then you're going to get started on the additional worksheet, which involves solving using the 4 different methods that we've learned about so far. So first, let's finish these notes. If you can recall from yesterday, we had to use the discriminant to determine how many solutions we would have for our quadratics. So that formula is d is equal to b squared minus 4ac. So all we have to do is identify our A, B, and C and go from there. So in number 8, A is 2, B is 1, and C is also 1. So I'm just going to go ahead and plug that into the formula. So D is equal to 1 squared minus 4 times 2 times 1. So again, you can just put this straight into your calculator, or you can go step by step and try to solve it down from there. 1 squared is 1. Negative 4 times 2 times 1 is negative 8. So 1 minus 8 is negative 7. Since I have a negative value, that is going to give me 2 complex solutions. On to the next one, number 9. X squared is equal to 0. Now, if you're looking at this one, you might be a little confused because, well, it only has an x squared, and there's no b term or c term. Well, really, a is equal to 1. The coefficient of x squared is 1. B is then 0, and c is then 0. It might be silly, but we can plug this into the formula for the discriminant. You get d is equal to b squared, which is 0 squared, minus 4 times 1 times 0. And if you simplify that, you'll simply just get 0. So from yesterday, we learned that if it equals 0, there is one real solution. One last one. So in this next one, we realize that, well, the x squared is by itself and the other 2 terms are not with it. So you have a choice. You can either move the x squared term or you can move the other 2 terms. It's just your preference of what you want it to look like. So you would just have to rewrite it. 3x squared minus 2x minus 3 equals 0. Or if you did it the other way, all the signs would be flipped. So it'd be negative 3x squared minus 2x minus 3. Plus 3. And you'll get the same answer. So A is equal to 3, B is equal to 2, and C is also equal to 3. So if you plug that into your discriminant formula, you'll just have D is equal to B squared, so 2 squared, minus 4 times 3 times 3. So again, you can plug this just straight into your calculator. So I'm going to do that now. 4 minus. You get negative 32. Again, that is negative, so you get 2 complex solutions. If it were positive, then I would have 2 real, but again, that negative under the radical means I'm going to have to put an I in my final answer, which makes it complex. So to summarize some thoughts from the majority of this unit, how many solutions does a quadratic have? Well, we've definitely seen 2 complex and 2 real solutions. So in general, there really are 2 solutions to every quadratic. So what does that mean when the discriminant is 0 and we say that there is only one real solution? Is this really going against what we said? Well, no, it's not. What is happening there is that the root, or the solution, is being repeated. So for example, if I had two factors, x plus 2 and x plus 2 equals 0, both of those answers would end up being x is equal to -2 and x is equal to -2. But I don't know about you, but I'm a little lazy when it comes to writing my math. So I don't really feel like writing x is equal to -2 twice. So more often than not, we see just x is equal to 2 as our final answer that we circle. So what's happening is you do have two solutions. You're just not writing it out as 2, so it only really looks like 1 because it is just being repeated. So let's talk about all the various ways we've tried to solve quadratic equations so far. So if you can remember back to our first days of this unit, we learned how to factor. And with factoring, there were so many different methods that we talked about, right? We talked about A&M, dots, GCF, and grouping. After factoring, we learned how to complete the square. After completing the square, we learned that, well, we can have complex answers. It wasn't a new strategy. It just, we had to remind ourselves that if there is a negative under the radical, then we have to put an I in our answer. So that wasn't a new method, it was just a new idea. So the last way we learned how to solve a quadratic equation was the quadratic formula. And those are all our different ways. So if you think about all the different ways, there really aren't too many that we can use. Oh, and actually there is one more, and it's the one I always simply forget about because it's the easiest way, which is the square root method. And that's when you already have like our x by itself, or you can just do the backwards PEMDAS to get the x by itself, and then you just take your square root. So here are a few different problems, and each of them are going to require a different way to solve it. So if I look at number 11, which method seems the best for this one? Well, it's x minus 1 squared. I don't have many terms going on, so get rid of that. So since there's not a lot of terms, I'm just going to go ahead and get x by itself by taking the square root. So this would be square root method. And when I take the square root of both sides, that allows me to cancel out that squared. So we have x minus 1 equals, well, 40 is not a perfect square, so I'm going to have to break that down somewhere off to the side. 4 and 10, 2 and 2, 5 and 2. Here's a pair. These two are not pairs, so plus or minus 2 radical 10. And then I only have one more step to solve for x. Add 1 to both sides. And I just put that in the front. So x equals 1 plus or minus 2 radical 10. So for this first one, square root method. And again, that's because we have that x as a squared almost already by itself. Not too many terms. Actually, there is only one term, and that's x being squared. If you can see in number 12, we have 3 terms, and we do have an x squared, but we also have a secondary x, and then we have a constant as well. So square root method's not going to be a good one for number 12. So what I can do for number 12 is make a decision based upon what number is in the front. Now, since there is no number in the front, I'm probably not going to want to use the quadratic formula because there's probably something a little simpler than that. So my options are going to be either maybe something as simple as factoring using A&M, or maybe completing the square. Now, I'm looking here and I noticed that right here, our B term is even. If you remember from class, we said, well, if the B term is even, you're going to want to probably complete the square. So let's go ahead and do that. So remember from completing the square, first you have to isolate those x terms. So you have x squared minus 8x, and then I put in my blank, plus blank equals 3 plus 1 is 4, plus another blank. To find out what goes in that blank, negative 8 divided by 2, which is negative 4. Always divide by 2 no matter what. Then you square it. When you square a negative, it automatically becomes positive. That's why I always put a plus before the blank. So 16. 16 goes on both sides. Got to keep it balanced. So from here, we learned that, yes, you can use add, multiply to try to factor that down, but there's that quick little trick that says in the parentheses, it's going to just be that number that was in the parentheses squared. Equals, go back to 4 plus 16, that's 20. Now from here, it's going to look very similar to the square root method, and it should, because that's the only couple of steps you have left. Take the square root of both sides. 20 can break down. 2 and 10, or 4 and 5 works as well. 2 and 5, so you have 2 radical 5. I'm going to go off to the side here. So x minus 4 equals, I need a special symbol, plus or minus, 2 radical 5. One more step. Add 4 to both sides. So x equals 4 plus or minus 2 radical 5. And you're done. So that's completing the square. Again, you're going to want to use it whenever you have B as your even term. Next one, again, I'm looking for that in front value to be 1, which it is in this case as well. So since it is, and this here B term is odd, I don't want to complete the squared. So I'm going to try and go back to the simplest idea, which is A&M. So all I have to do is ask myself, are there 2 factors that multiply to 28 but add to negative 11? And that might take some work. I might have to go through my calculator if I can't think of it right away and play around with the number 28 and see what it breaks down into. So 28 breaks down into 4 and 7. There are other ways to break down 28, such as 2 and 14. But 2 and 14, there's no way to add or subtract them to get you negative 11. It's not going to work. So I know that that's not a good option. So I'm going to play around with 4 and 7. And, well, negative 11, I know 4 plus 7 is 11. So if I flip both of their signs, negative 4 plus negative 7 equals negative 11. And the nice thing about the add multiply method is that you put them into the factors right away. So x minus 4 and x minus 7 equals 0. And you can make your choice if you want the 7 to go first or last. It does not actually matter, because all that matters is for me to find my 2 answers. And my 2 answers are going to be positive 4 and positive 7, because we're just going to flip those signs. And that's it. Now for number 14, in the past we said, well, if the number in front is not 1, we got to try to see if we can factor out a GCF. So I'm looking at number 14 and I see a 3, a negative 1, and a negative 1. Well, none of those have a GCF together, so can't pull out a GCF. Now, I could go ahead and try factor by grouping, but I know how that's going to go, and I don't think you guys want to do factor by grouping. So we're not going to do factor by grouping, and instead we're going to go ahead and use the quadratic formula because it's always going to work. So anytime that you have a number in front, quadratic, go ahead and use the quadratic formula. It might take you some time to do it, but it is going to work, especially when you have a number out front and you cannot divide. So the first thing in the quadratic formula that we're going to have to do is we are going to have to know what our A, B, and C terms are equal to. So we have 3, -1, and -1. So when that happens, or when you figure those out, rather, you're just going to plug it into the quadratic formula. So x equals, opposite of b is +1, plus or minus the square root of b squared, so -1 squared, minus 4 times a times c, so 4 times 3 times -1, all over 2a. Once you have that plugged in, you just go ahead and simplify within the radical. So I'm going to rewrite. 1 squared is 1. -4 times 3 is 12, times a -1 is +12. All over 2 times 3, which is 6. Simplify one more step. X equals 1 plus or minus the square root of 13 over 6. Now, all I have to do is check, can I reduce any numbers in front? No reduction, so that's my final answer.